Okay, so let's start with this program. Can you tell me how many printf it how many line it will print? How many process it will create? Any idea how many can you get? See the code and try to find how many process it will create. 32 or 5? More than 5? So it's like look like the purpose of writing this code is I need to create 5 child process, right? But actually it is not correct. If you think that if you want to create 5 child process and if you write like this that every fork will create one child process, and if you repeat it 5 times then it will create 5 child process, then it is wrong, right? So I can show it to you, show this thing to you here. GCC simple. See, there are lots of process, not just not just 5. Why? Because of fork here. Last class also we have discussed this, right? That writing fork inside a loop is dangerous because it will create lots of process. Why? Because after the first fork, the next immediately from next line, all of them will start executing. So when I equal to 0, that time it will go inside here and it will execute fork first time, right? Look something like this. This explanation is for those who have not understood it. I think some of you have already understood, but I'm explaining it for the suppose for I equal to 0, it will go for a fork. And for this fork, there will be two process. One is already P1 and suppose P2. After this fork, there will be two process, right? P1 and P2. So now what I said in last class that immediately after this fork statement, next statement will be executed by both the process. So the next statement here is printf. So printf will be executed by both the process. That is fine. But what is after printf? After printf is again a loop. So it will go back again and it will start executing from I equal to 1. Okay. Why I equal to 1? You may, if you think like that I equal to 1 was initially proposed for P1 only. Whenever you are creating a new process, last class I said all the variables and all are copied to the new process. Right. So now when you reach for I equal to 1, and there also there is a fork statement, right? This is what second iteration. But in this iteration, the same thing will be executed by P1 as well as P2 because from the after this line is simultaneously executing by both the process P1 and P2. So now when P1 will execute fork, it will create one more child. Okay, so from P1 maybe P12 will be created and the same time from P21 will be created. So next then it will go to the next iteration. So that's how there's lots of process will be generated. And this is not the correct statement for creating 5 child process. Okay. So now the question is what modification you can do? What modification you can do here?
Child process will break the loop.
Huh?
Child process will break the loop.
Okay, good. Just see what I am writing here. Instead of showing a long program, if you see it building here, then maybe you'll understand it better. That's why I'm trying to write it here. Now, what will happen? How many process will create now? If I run it now, okay, let me run and then we'll check. One, two, three, four, five. Five processes. See, one is showing here also. So total five process. Five child process has been created. This is the expectation. That exactly we are expecting from this code, that there is a for loop which is iterating five times. And every time our intention is to create one child process. If your intention is to create child process, then you need to go after fork, you need to check what this value is returning. If you need to only handle zero, because if you just write fork, then next line will be start executing by both parent as well as child. Let's see, whatever I have written is the short form of the file that I have written in last class. So if you see this file, not this file, this was the file that I have shown you yesterday, right? If you relate with this, the same thing in only I have written in short. First, you can write PID equal to fork, and then you can check PID 0 on. That was the code for yesterday, and today I am just using the short form here. The same thing, I'm directly checking here. So basically, these two lines will be executed only by the child process. The main parent process will not execute this one. Okay, so what this child process is doing here, hello, my process ID is this, and then it is terminating. It's not doing anything else. It is exit 0 means after this line, this particular process will terminate. So that means it is not going back to the iteration. If you miss this one, then again the same story, because it's fine that it will not print, but you are not stopping the child process also. If you're not stopping the child process, it will go back, right? So this exit 0 is very, very important here, that okay, whatever you want to do with the child process, do it, and then you exit it here. And in last class, I have shown one more code. If you remember last code, I think if you remember this code, what was the purpose of this?
It's not same as parent.
Yeah, so so in you first create a child process, and in child process you can start any other process. If you do this, then you no need to go for an exit here. Suppose the same thing you want to do, that you are creating a child process only because you want to run something else here. If you do this, then it is fine. What will happen? Then these code are not relevant. This code after this line, this process will be replaced by another process. So in that case, it will not go and start executing from here. Because if you write this code and based on this you want to run a different process here, then these lines are not important, because these will be replaced by the process that you will start. Okay. So in that case, this is not relevant. But if you are not doing this and this is your code, then exit 0 is very, very important. Okay. Okay. Now I'll show you something more interesting. What extra code I have added? This while loop. What is this while loop? Just to keep the process alive. Which process it will keep alive?
The parent, first parent.
First process only. Agree, all of you? See the code. I'm saying that the line, that highlighted line, will only keep the parent process alive, not the five child process. Because five child process will exit because of the exit 0 command. Right? So whatever five child process the for loop is creating, they will be just they'll take use this printf, they'll print that message, and then next line is exit. So child process will exit or child process will terminate. But the parent process is alive here. Sleep means it will go to idle mode. After some time, it will again active, but it is not terminated. Okay, so it is not terminated. So now if you run this code, see, so now all the five child processes, they are just printing hello, my process ID is this, and they are terminating. But the parent process is still alive. That's why it is not the main process is not terminating here. Now, if I try to see the list of processes, what do you think? What should I get? Only, only the parent, right? Because child process are terminated. So if I now go for PS minus AF, I should get only the parent process, right? I should not get the 4, 5 child process. But it's not true. What actually happens here? They are not active. You can see this message here last. This message is there, right? For all the child process. These processes are called zombie process. Okay, this is a very important term. You need to remember what is zombie process. So what is called zombie? If you remember, let us go back to the yesterday code and remember this term wait. What was the purpose of wait? I said there is a purpose, right? What is the purpose? After it will wait for its child to terminate. So now if you see the exit code here, exit 0. So you already know the purpose of exit 0, right? Exit 0 will terminate that particular process. It will release all the resources. It doesn't mean that whenever a child will terminate, all the resources will be released. Only thing remains is the process ID. Process ID is maintained in the kernel. Inside the kernel, there is a table called process table. Inside the process table, the ID will be there. You cannot assign this ID to someone else. Like suppose one of your friend left, and then you cannot just assign that particular roll number to a new person, right? Unless you officially remove, otherwise you cannot assign. Same thing here, though the process is terminated, but removing the process ID from the process table, it is the responsibility of the parent process. If the parent process is alive, connect all the things. If the parent process is alive, if the parent process is alive, then it is the responsibility of the parent process that the process ID of its child process should be removed after the child process is terminating. So now what is happening here, if you see, child process are terminating, right? Parent process is still alive and parent process is not taking care of it. See why? Because if you see it, there is no wait here. It is just, yes, the parent process is running, it is doing something else, or it is waiting for infinitely for for some other task, but it is not waiting here for it. Wait is the command where the parent process collect the information that, okay, this child has been terminated, so let me remove the ID, or it will just inform the kernel that remove the process ID from your process table. But it is not happening here. And that's why these processes, though they are terminated, they are not using any other resources, like they are not using any main memory or anything else, but they still have a process ID. And you cannot assign this process ID to something else or some other process. And that's the problem. Okay. So these processes are called zombie process. So now what will happen? Another point here is, which one is the parent process here? I think the parent process here, which is alive, parent process is 2325. So now if I kill 2325, and now if you start, then they are not here. So it means that if your parent process is terminating, it is not taking care of it. Let's move back to the code. Your parent process was not, there is no wait command in parent process. So parent process is not handling the terminated child process. At that moment, if you killed the parent process, then the ownership of all these child process will be taken care by system D, and system D will automatically terminate them. So in this way, OS is handling it. But the problem is, suppose someone is trying to create a attack application or something, and it will create a parent process, and it will create many child application process, and then after terminating them, it is not taking care of them, and it is the process is still running, like in same condition, process is still running. Then there will be lots of zombie process in the system, and because of that, the process IDs will be exhausted. And after some time, maybe if the process cannot, the OS cannot start a new process because there will not be enough process IDs available. So those problem may happen if the parent process is still running. That's why as a good programmer, you need to handle it. And because of that, you always need to write wait command. Okay. Some more concept I'll show you here. How many process numbers are possible? I think u limit minus u. 31149. This is the maximum number of process that I can generate. I means here my ID is Sirshendu here. So from my user ID, user account, I can only generate this many processes. And what is the total number of processes? I forgot the command. I have written it here. I'll just show you. Total number of process possible in this machine is this. So obviously, if someone is trying to attack by writing a parent process, which will create many child process, they will terminate fine. They are not using any other resources. But what will happen if they are not removing from the process table? Then it will create a problem for OS, and that's why you need to handle zombie process efficiently.
Sure. So,
Huh?
so processes are already terminated, then what is use of storing them as zombie process?
What is the use of?
Storing them as
Yeah, so that's the responsibility of parent process to remove it. If the child process is terminated, someone should remove it from the kernel entry of the process table. That responsibility is given to the parent process. There are some restrictions are there why kernel is not directly removing it. It should be the responsibility of parent because there are many other things. You will understand here, but I have an example that after terminating, parents should also take care that which child process has been terminated and all. So based on that, this power is given to the parent process. So if the parent process is alive, it should handle it. Otherwise, it will create a problem. So there are many other ways to handle it, but I'm not going in much deeper way. But this is the high level idea of a zombie process.
So when there's a parent process and child process, parent process takes child process being assigned to the
System D. And System D has a efficient code. So System D will automatically find out that, okay, these are the process already terminated. Now they are zombie. So they will, it will remove. System D will remove. Only problem is if the parent process is alive and it is not handling, then it is called zombie. Otherwise, it's not a zombie process.
So without terminating of parent, if parent wait, it will is
Without terminating the parent, if we,
right wait.
that is the actual thing that we need to do. So what we'll do here is before not while or whatever it is before that the parent process should write something like this, and here they need to go for wait or wait PID -1 null 0. Wait PID is also purpose is same of wait. It's another function. Purpose is almost same. It will also one by one it will if one child process terminates, then this can catch it only once. If you just write it once without you writing this for loop, then it can catch only one terminated process. You need to catch 5 terminated process, right? That's why you need to write it inside a for loop. So this function will return which terminated process it has served now. So if you write this, then it will print which process has been terminated. So I hope I have written the code correctly. Just let me run it. There may be syntax error. So now 1, 2, 3, 4, 5. So you can see the 5 processes are starting, 5 processes are terminating. Display can be in different order. Don't think about the display here, but you can see 5 child processes are creating, 5 are also terminating. Why? Because of this code highlight. I'll show you the code, which is the responsive. This is the code. This is the code of parent process. This is running only in the parent process. So it is, and now if you concentrate further and go for this code, then here this process is waiting. This is catching one terminated process. It is removing all the details from the process table. Then it is saying that this particular process is terminated. It is already terminated, but here it is removing from the, or it is successfully handling it. Do you know about exceptions or try catch? Something like that. If you have exceptions, you need to handle it. And if you have an exception, then it will go to the catch part, right? I'll explain try catch when I'll explain C++. Sorry, Java. Okay. So now if you repeat it for 5 times, then all the process will be what you can say terminated successfully. But now if you want to maintain a order, there is no specific order here. Okay. So and also if I don't want to go for this and this exit, suppose if I replace this exit with this code, infinite loop, let me just write it in a single line. Hmm. Now what will happen? If you run it, then all the processes are running. Then let me open a new window. I'm going for more detailed explanation as for assuming that all will not understand directly. So that's why maybe some of you have already understood what I'm trying here. Now I'll kill one process, any process, 2400. Right, 2400. You can see here this is the child process running. Automatically, you can see the process 2400 terminated. Can you see here? So now what is happening if you go to the code, then this because of now exit is commented. So the child process are also not terminated automatically. They are just printing that hello, this is my process ID, and they are also running infinitely because of this while loop, highlighted while loop. So basically, all five child process are also running, and the parent process is also running. And parent process is waiting here. Parent process is just waiting here for the wait PID. So what the moment it will one will be terminated, this will catch and it will say that okay, this one is terminated. Now let's move to this setup and try to kill one more 241. So this 241 is terminated. You can there is no order, you no need to maintain any order. You just kill one process and automatically the parent is ready to handle that process because of the for loop in the wait PID for loop. Okay. Huh?
That is in the next farm.
Ah.
So previous farm that is interpreting update from outside and come to the
You should have understood it from last one or two lecture. See the two for loop. These two for loop are not running in the same process. The first for loop is in the child process, and this for loop is in the parent process. Okay, it is clear. If it is not clear, then feel free to ask question because this is very important concept. Why it is important and what question he asked. This is a very good question. Why? Because this type of question will come in your mind. Why? Because so far in your life, whatever code you have written are always running in sequential. Right? Suddenly from last two lectures, you find that no codes are not always running in sequential manner. That's the difference. So maybe you are writing code from last 3-4 years at least. And every time you see that codes are running in sequential order. But now you can see that it's not true always. And that's why I think first class I say that you cannot say that you know one particular programming language if you have not written any multi-threaded code. It's not multi-threaded, but yet there are multiple processes. And in complex code like this, it's true that it will not behave sequentially. So this highlighted code is running in one process, is the parent process. And whatever I have written here, these are running in all five child process. So they are not same. Okay, so now what I'm trying to explain from this diagram is you can kill any or whenever one particular child process will terminate, parent process can handle it. The way I have written the wait PID here. There is no fixed sequence here. There is no fixed sequence. But you can write it also in a sequence that no, I don't want to handle the child process in any, I just want to handle child process in a fixed order. So now, yeah, this is also important. Now what I have done by pressing Control C, I terminate the parent process. If you terminate the parent process, then there is no more zombie. Yeah, but I think this process are running, right? The child process are running. But the running process are there. No, they are also closed.
They not noise.
Oh, yes, yes, sir. No, it is not there because maybe when I press Control C, all of them are closed. But if it is not for kill, because I press controls here, right? So maybe all child process also close. Okay. Okay, now the next thing is, suppose I just want to handle them in sequence, then what you will do? Then you can also write a particular PID here. Instead of -1 here, instead of -1, if you write a PID of a particular child application, child process, then it will wait for that child process. Okay. So now, if I change something, that instead of this, I let me use a PID array. Suppose array of 10, and this one is PID. Okay. And then did you understand what modification I have done here? Now I'm creating 5 child process, and I'm also storing their PID. And where the PIDs are stored? In this array. Huh?
Get PID here.
Get PID?
Like 4 will return 0 for child process.
Huh?
Get PID 4 PID.
For child process. And what it will return in parent process? A good question, but next step I'm saying, whatever you said correct, but what it will return in child process, for the parent process. The idea of child process, right? So this code that I have written here, this line will be executed by both parent and child. So that's why the things are slightly complex. You need to spend some time. So this particular line will be executed by both parent and child, but next 3 lines will not execute by parent process. But in this case, this PID, the array is only generated for parent process. Parent process will maintain a list of all the child process IDs. See the first line, there is a global variable of array. That will be copied with the child process also. But in child process, this array is useless. Okay, but in parent process, this is useful. So in parent process, this array will maintain the list of all 5 child process. And when I'll create all these things and I'll reach here, in this case, in parent process, I have an array for PID. And
If you write PID of it, it will overwrite.
oh, here local variable.
I mean, in the first subgroup, PID of I equal 4 equal 0, equal 0. In that it will overwrite. Which will execute second time, it will get saved.
But I class is there in the for loop.
Yes, sir. I mean, for I equal to 0, parent will be run or child will be run.
Yeah.
Which one will run first? It will be stored, right? I mean, it will still run second, it will store. 0 will be run.
Okay. For I equal to 0, right? When it will run for I equal to 0, first child will create. It will store in P0, or array 0.
First parent will be run or child will be run.
First parent, so when fork is running, what is executing is not important. This line, this particular statement, this line is executed in parent process first or child process first is not important. They will run in 2 separate code. But this PID will be copied, right? PID is an array. There is a copy for parent, there is a copy here for child. I don't think about what is happening in child process. I only need to maintain PID here in parent process. So that's why there is not a problem. Okay, clear? So now when I reach here, I have a list of only parent will reach here. First of all, the highlighted area, child will never reach, right? That is clear, right? So whenever I reach here, I have a list of all PIDs, right? So now what I want to do is I just want to I don't want to write this, and I obviously I cannot use PID because this is the same variable I've already used. Suppose it is PID1, and instead of this, I can write here PIDI. So what will happen in that
Print.
print?
PID wala.
Yeah, thank you. Now it is waiting for first child to terminate. So now what will happen? Suppose if you terminate the 5th child, then it will become zombie for some time, because parents says no, first I will handle the child 1 and then I'll go to child 2. I'll go in a sequential order. So in that case, if you run this code and you manually kill 5th child first, then that will be a problem. But it will not create a only if there is there is an infinite loop here. If there is an infinite loop here, then only that problem will come. Run it and then you will understand. Okay. If it is running, now you go here and try to kill, which is 2453. Okay, it is handled. I think it is maybe the process one. Maybe I'll go for 2450. The code is not updated, I think. Let me check. Code is updated. PID, it should wait for PID, right? Then simple for loop. Okay. Loop one. All processes are running. So now if I kill, suppose 2463, I don't know. It should not happen like this. Because it is waiting for a particular process here. That process should handle. But yeah, I need to cross check. But this is the purpose here, that it should terminate the process sequentially. Maybe the ah, because of that, the error was coming. So now all processes are running. Now if I kill 2504, this is the fifth child, right? So if I terminate fifth child, it should not handle it here. Why parent is not handling it? It is now zombie for some time because parent is waiting for terminating the first child. So now if we kill first one is 2500, then it will handle. Okay. So now I was just trying to show a small example, but unfortunately there was a error. I have to spend a lot of time. Okay, so zombie process is clear, I think, right? And this purpose of wait PID is also clear. What is the purpose of wait PID? You need to, if you want to know more about wait PID, there are different, this is a overloaded function, and there are a lot of different options are possible with it. I'll share a video, you can check it, or if you want, you can explore it also. But whatever I'm teaching here is enough for this course. If you just think about the syllabus of this course, then whatever I'm teaching here is enough. You no need to explore more. But if I'm giving you any assignment and there I'm saying explore more, that's a different thing. And if you want to know it just for your knowledge, then I'll share some videos that you can check those videos, you can explore it through ChatGPT also. Why I'm saying only ChatGPT? Because here you can ask questions. Any doubt you can ask. If you search it in Google or somewhere else, then you cannot ask your doubts. That's why it will be easy and fast, easy to understand if you are going through ChatGPT. Okay, so this is done. What else? That I have zombie. I have explained. Wait PID. I have explained. Importance of wait PID is clear to you. The next important point that I'm planning to explain today is scheduler. Okay. For scheduler, I don't need this code. I don't need this code also. I'll just use this simple code for scheduler. Yeah. So now what is scheduler? Scheduler means if you have multiple process running, suppose you have 100, I'll just show you that how many process at present are running, right? If you go here, see the lots of process are running. And all these processes are also just user process, user domain process, right? You can see currently this much processor running. These all are user domain process. This much processor running. And I think if I go for WC minus L, 33 processor running. Okay. So why I'm saying 33? Okay. Maybe if I am using it, I have to also explain it. What is PS minus EF is clear to you, right? It is just if you write a command, then all the user space process running are showing here, right? But see the first line. First row is, it's like a table, and first row is a header. First row is a header. So how many rows are there? There are actually 34 rows. So how many processes should be there? 33. First row is a header. So what WC is doing, this is called pipe. If you write this, then this last one, this part means it will only act on the result that will create by PS minus EF. The PS minus EF will display this result, right? That I am showing in the screen. And on this result, WC means count the watts. This is a watt counter. And minus L means line counter. So it will just count the line in this output. If this is called pipeline. So after this command, whatever I have written here, after this line, vertical line here, it means that it will act only on the result of PS minus EF. PS minus EF will give you this result, and it will now WC means watt count, but WC minus L means line count. So it is saying 34. If you run it, 34 means, but you understood that the first line is not required, right? So it will be 33. If you don't want this, then also there is you can make it even more fancy, and you can just add no headers. Or maybe I'll just write this. Then 33. That's why shell command is very, very powerful. Whatever I'm writing here, a Linux command or shell commands. So we'll spend 1 week on this also. But one way is whatever I'm writing here, whatever command I'm writing, it's may or may not related with process or a zombie process, whatever I'm discussing. You also need to concentrate on this command, that what I am writing here. These are also important. These, whatever I'm saying, it will be required for lifetime. It's not just for this course. You need to, and if you remember these commands, your life will be very simple. Okay. So now there are 33 processes are there. And how many processors are there? How many cores are there? In this laptop, there are 6 cores because it is Intel i5. Intel i5, which generation I forgot. There are 6 cores, physical core. But each core has 2 threads, right? What that thread is called? Hyper threading concept. So each core is actually working as 2 threads. This is not the software thread, or this is not the thread of OS. It's a hardware thread. So basically each core you can consider as a 2 cores. So there are 12 cores in this laptop. 12 core and 33 processors running. So how it will run? What do you think? How OS is running them? It's not possible that at particular time 2 processors running in a single core. Is it possible? Whatever knowledge you have from this course from the beginning, try to apply this and rethink how computer works. One by one, CPU request for a address based on the program counter. It will go to that address, fetch that instruction, execute it. At the same time, it's not possible that, okay, first program counter is from this process, second program counter is, that is not possible, right? I just said program counter will be incremented by 4, right? So next instruction. If there is a branch instruction, it will jump, but it is in the same address space for same process only, isn't it? If you remember, in process, there is a particular segment for code. So it is from that code only, it is not from other process. So at a time, one core can execute only one process. There are multiple processors there. Process is more than the core. If you have a single core machine also, in Linux, so you can do something like that. Also, you can stop other cores also. Then also you can try running. If you are running 2 different applications, both will run, isn't it? Suppose you have 12 core here. If I run all the process, everyone will run. Why? Because it will run based on the time sharing basis. These are called simultaneous execution. And one process will run for some time, then it will the OS will remove it and then assign another process. This is called context switch. The context switching are happening, and based on that, all the processes are running. So now this is fine, right? We have used this PS minus EF. So if you run this, I think the which one is the core? PSR is the core, right? 6, 11, 7 means what? The process is running in this core. Okay. Let me watch minus N 0.5. Oh, now it is actually the number of cores are a lot. That's why it is not. Okay, I'll show it to you. The problem is, I think that there are more number of cores here. That's why it is not showing. Anyway, I'll come back to this point. Okay, this is the same previous program. How many process it is created? 5 child process, right? Now, if I go back here and I just write PS minus AF, it is displaying all of them, right? And see the process ID. Now, can you see something is changing? So for loop 1 and loop 2, this process is changing very fast. These are not my program, but still the process is changing. And if you see the top one, these are our codes. The process ID is changing, but it is slowly changing. If you closely observe them, changing. If you run for 5 minutes or 10 minutes, you see this upper this loop 1, loop all the child process, including the whatever process I have started, their process core ID will also change. This is the core ID where the process is running. And you see the bottom one are the bash. So they are constantly changing. So it means that there is a scheduler there in OS, and scheduler is a very important concept. That scheduler is responsible for scheduling that which process should execute in which core, and also there it's not like that each core has only one process. There are two steps here. First step, which process should go to which core, and each core there will be list of process, right? If there are 36 process suppose, and you have 12 core, then for each core there are 3 process, right? Then within the 3 process, so in each core there will be 3 process in queue. Then again you need to schedule out of these 3 which one should execute now. After some time which one should execute. So here if you have a multi-core machine, 2 things are working here: simultaneous execution as well as parallel execution. Simultaneous is within the core. If you have a 3 process you need to run within a core, you will run it based on context switch. As a human you cannot see the difference because the context switch is so fast that for human you will say that all 3 are running at the same time, but all 3 are not running at the same time. Only one is running at the same time, and that is the difference. And it is just sharing it very frequently, very fast. The time it changes, so the time sharing is very fast, and that's why you cannot observe it. But that's called simultaneous execution. But if 2 things are running in 2 different code, that's called parallel execution. So both simultaneous and parallel executions are happening here. And that's why, see now I think some of them are changed, right? There was 0 here. Now I can see it is 11 or 4. But the process is still changing. That is the purpose of scheduler. Now I'll show you something else. I think there is one more command. I forgot that command. I think top. If I go for top, then should show the CPU uses for my programs also, but it's not showing. I'll maybe the number of. I'll show you the top. I've written it here also, I think. Okay, now let's move to this program. I'll come back to this again. Now let's move to this program, and I'll run it in 2 different core. The same thing I'll I think this code is simple live. You don't need to understand the code. Basically, it is also an infinite loop. But why I have not written sleep here? Sleep means maximum time this process will be in ideal mode only. Sleep means you are saying sleep for 2 seconds and then it will wake up, right? Then what is happening in CPU, it will stay very less amount of time. If you write a process and instead of writing I plus, if you write sleep, it is also infinite loop. But if you go and check the status of this, it will show that this process is not running. Why? Because whenever you will check it, it will be not in CPU. It will be in ideal state because sleep means that time it will not be in CPU. CPU will be used for something else because number of processes is more than the number of core. So if you say that no, this is a process which should go to sleep now, then that will not stay in CPU because CPU is important and someone else, some other process will come to execute here. So if there is a sleep here, if you whenever you try to check the status of that process, you will say that it is not running. Why? Because of this for context switch. But I plus plus means it will always run. Okay, so now this process is running here.
So
What?
what is one thing?
Huh?
One thing, sir.
What I'll do? I'll run the same code from here also. The same code I'm running from two places, right? So now if I go here and try to check how many processes are running, then these two processes are generated by me. So one is running in 6, one is running in 2. See, now from 2 it has changed to 3, right? So this is how the process will change here. Now I'll show you one more thing. Now I'll not run it like this. Let's stop it from here. And I'll run. Suppose you want to run both in same code, then what you will do? I'll write task set minus n. Just let me check the syntax. Yeah, task set minus c, sorry. Task set minus c8. Simple. What I am saying to OS is my program should run in this code only. I want to run this particular process only in core 7, core 8. It should run here only. Same thing I'll say here also. So now what I have instructed OS that my code should run in this particular core only. And that you can do it task set. It's called core binding. You can bind your process where in it to run. So both are running in same process. Now if I go here and check, go for it, same thing. Watch 8, right? If you see both this is also 8, this is also 8. Both the programs are running in same process. Why? How? Because of task set. If you go here, I have instructed, I have not just run simple, I have written task set. And because of task set, this is how it is working. Okay, so but the thing that I was trying to explain to you is something different. If I write top here, what it is showing, yeah, there is a command called top. If you write top command, then it will show you the current status of all the process. I'm not showing the details of top here, but just check the CPU utilization. So yeah, if you see that these two process, both are running these two process 3598 and 3599. If you check here, then 3598 and 3599 both are running on core 8. Is it possible that they will run in parallel? Not possible. They are running in simultaneously. Then you need to know what is the time sharing. So time sharing is showing here almost 40% of the time CPU first the one process is running, another 46.8 means 47% they are dividing. Maybe the core OS is using the remaining time for some other process also. So you almost equal time sharing is there. Equal time is given to first process. Equal time is given to the second process. That I first process, second process means 3598 is the first process. 3599 is the second process that I am saying. Almost equal time is given, and that was showing from here, right? So now I think one process is almost done. I think that's why the sharing is not. Oh, now maybe the another process is go as okay. These are the two processes. So the same thing there. 47, 47. Okay. So now let me stop this one. Let me stop this one also. Now I'll show you one last thing here. Oh, there is one more command that no, though I am assigning two tasks to this particular code, but I want to emphasize more on this particular code. This you should give more time to this particular process and less time to the other process. That I think you need to do with nice, yeah, nice minus n. So nice is I think it varies from -20 to +20. I think I'm not very sure. -20 means top priority. So I think and 10 means you are saying that no, give this very less priority. And so I'll run it here. And here I'll just run it with the same old command. So here I have not said that you go give less priority to this. So here the priority will be high, but the other one that I have run, that is also running for core 8. If you go, this should also run on core 8. This will also run on core 8. But here I have written nice. So for nice, the priority will be very less. Now in this case, if you go to top and try to check the utilization, see the utilization. One is 85% time. The first process is running using the core for 85% of the time. And the other core is just using it for 9 to 10%. Because that's why that this is exactly the same thing I want, right? That's why I have given the command nice. Okay. So now you may ask a question that why I'm showing all this thing to you. This is not just for showing. I am trying to explain you the scheduler. Whenever a process is running, you may be not doing them manually. What? Scheduler is doing it for you. So it will understand that which task is the high priority task, which task is a low priority task. Based on that, if there are multiple processes are waiting for the same core, right? For the multiple core is there are multiple for each core will be a queue, right? So if for this particular core also there are multiple processes waiting, then the scheduler will understand that which one is more important, which one should I give more priority and all. So process scheduling itself is a big area, not just for learning. It's a research area also. So many new scheduler algorithm is proposing every day where people are trying to analyze the difference between existing technique and what are the limitations. So scheduling algorithms is itself a big research area. But I'm just explaining the basics of from where it is starting, the need of a scheduler. So in OS, there are two, three things very important. One is scheduling. Another is called process synchronization. That I am not explaining here. I don't think I should explain process synchronization here. Whenever you learn OS, you have to spend a lot of time on understand process synchronization. And because now what the way I have explained that every process are independent. It's not always true. Sometimes there may be some common variable or that's something which two, three process may need to execute. I'll give an example. Suppose for IRCTC ticket booking, every time you, as from the client machine, whenever you send a request, it will create a separate process or it will create a separate thread for you. But the ticket value should be in a local position, right? What happened here, that there is a global variable called PID. Whenever you're creating a child, what is happening? A separate copy is creating. The separate copies will create, then all the tickets will show available for you, right? That should not happen. Those variables should be used by all the process, isn't it? So whatever I am saying is true, fine, but they are not always you need to follow this. It may be this situation will also come that there are some common variable or common memory that multiple process need to update. And that time it is very it's a very critical situation. And this is a big thing, part of operating system also, how they will handle it. Otherwise, suppose there is a variable called X and both the processes are trying to increment it. If that increment is happening at the exactly same time, then suppose the previous value was 5, next value will be 6 only, even after 2 increment. Why? Because how increment will happen? Both of them will read the value. Suppose there is a value here called 5, x equal to 5. and then that value will read by both process P1 and P2, and their purpose is to execute X plus plus. So what should the value of X here? What you are expecting? 7, because there are two X plus plus. Do you think sometime it will be 6? When? How X plus plus will happen? First of all, it should read the value of X. Then X equal to X plus 1. That is X plus plus. So you can only increment it after reading it. So when you are reading, if both of them read 5, then X plus plus in both of them will just do it 6 only. So that's the problem. How you will resolve it? What should be the exact case? Both of them should not read the old value. That's why this operation should be 6. Though they are working in parallel, suppose. It is in code 1, suppose it is code 2. Though they are working in parallel, but there may be some critical cases that should not execute in parallel. And this is one of the critical case. But other thing, many they are doing some other tasks, suppose. In that case, two processes are running in parallel, they are doing two separate tasks. It's the very good thing. And because for that, exactly for that purpose, the multi-core machines are there, right? But there may be some critical situation like this where if they are trying to access the same variable, in that case, if you allow them to access in parallel, this type of mistake may happen. In that case, you can say that no, this X plus plus is a critical part and only one process can execute it at a time. First one should execute it, read 5, make it 6. That time other process is not allowed to do anything. Once this is done, then this process will start. And then whenever you read, it will read 6. And then it will make it 7. Then only will get 7. Can you relate it with some ticket booking that I'm saying about IRCTC? Otherwise, same ticket will show available to 2-3 of us. And maybe all of will get the same confirmation number for same seat. That should not happen. So this particular code that will run in, it should run in a critical section. So how to handle critical section of a code? All these things you will understand in process synchronization. So I have the long list. I'll share a complete playlist with you. In that playlist, I have videos for all this. But you can check now, or if you want, you can check it when you will study OS. Okay, so I think most of the things that I have planned today is done. So I'll share all the code with you, and you start. You need to practice it. If you don't practice, then you will forget everything. My suggestion will be there will be 3 recorded lecture, including today. I'll share today's lecture also. Watch these 3 lecture, create your own notes, and then only you will remember it. Otherwise, you'll forget. And these command and all that I am showing, these commands are very important command. I'll suggest you whatever command I am writing, explore this command, because suppose this command ps minus e, you can also use ps minus af, right? There are different options possible with this. Try to explore the ps command. You can either write man ps here in command prompt. If you write here, right, man ps, you can see the manual here. Either read the manual or spend some time on ChatGPT to understand. So whatever command I have used, you just list all the command also separately and spend some time on command. Either is related with fork or whatever it is, right? Top. What is top command? I have used a command called watch. I have not explained what is watch. I'll not mention it here also. You just spend some time and understand why I have used watch and what it is doing. Okay. Do you have any question? Otherwise, I'll stop.